Hi, my name's Matthew, and this is my automatic dog feeder. It was a requirement to design a dog feeder that had a feeder, a buzzer, and a weight sensor, and fed 2 dogs on intervals required. My design was a cube with a feeding tray at the front and a weight sensor. C program used interrupts and a switch statement to switch between the state model. There was an idle, play sound, a detect dog, and a feeding dog function within the code. There's also many other functions, including use of the interrupts for the Bluetooth, which was the X factor. The wiring diagram centered around the AT Mega 2560 controller includes the use of a stepper modem and a control board, the Bluetooth HM10, LEDs, switches, and the 2 HS711 adapters. This is my automatic dog feeder, the final product. As you can see, it's a cube, approximately 30 centimeters by 30 centimeters in each direction. Encased inside is PVC tubing for the storage and dispensing of the dog food. See the switch buttons and LEDs on the side, the sensor pad for the dog, and the feed bowl at the front. The feed bowl is supported by a weight sensor, and the detector pad is supported by a weight sensor also. Turning the device on for the demonstration, the bottom left hand corner you can see a continuous feed, which we will cut to shortly. But inside the dog feeder you can see the PVC pipe. There are a couple of T-junctions, and you can see the controls using jumper leads between a breadboard and the Arduino controller, motor controller to the left, and a battery mounted on top. The stepper motor is at the front of the PVC pipe and pulls the feed through the PVC pipe. Spiral auger is inside the PVC pipe and pulls the feed through, turning it in the video to demonstrate the feed being pulled through the feeder. You can see the feed gets pulled through and then drops out through a T-piece. Okay, the video that's been playing in the bottom left hand corner is approaching the 50 seconds for the feed of the first dog in the demonstration. A 300-gram tin is placed on the sensor pad to simulate the small dog, and the feed is distributed. Once the 10 grams of feed is detected in the bowl, the third light goes out. As you can see, first light on the right is the power light, followed by the timer light. So the timer is on. Place the feed there so we can compare it against the large dog. The large dog feed is turned to feed now. However, I've missed its feed. I wasn't quick enough with this one, so it actually didn't feed it, so that skips the feed because the dog wasn't there in time. With my controller, I also had the Bluetooth HM10 connected, which was used for my X factor. I connected through a second USART, so the USART 1 was used, with as long as the interrupt on the RX line of that USART. That allowed me to not only control but also program and configure the dog settings, the profiles of up to 10 dogs, including their name, their weight, their feed intervals, the amount of feed for each of those dogs, as well as a unique tone for each of those dogs. I've pre-programmed a couple of tunes in that can be chosen from, and we can hear the go up for the multiple dogs. So as it's time to feed the small dog again, the tune's played. the dog isn't present, the feed isn't distributed for the dog. Okay, so we'll wait for the large dog to be fed. When the large dog is fed, then we can compare the 10 grams that was dispensed for the small dog to the 30 grams dispensed for the large dog. So to simulate the large dog, I use two cans, a 400 and a 300 gram, which gives approximately 700 grams. And the feed is dispensed. And once the 30 grams of feed is detected in the bowl, it stops dispensing the feed. There's also a timeout included where it's weighing the feed, and if there isn't enough feed within a certain time, the automatic dog feeder will actually stop feeding, stop trying to dispense that feed. Will either light up the fourth LED on the left to indicate that there's either out of feed or there's a jam in the system. So I'll compare the 10 grams from the first dog to the 30 grams. So it should be approximately 3 times as much visually for the two feeds. And you can see it's about 3 times as much. So the 30 grams for the larger dog was dispensed. Okay. The PVC pipe at the top has adapters coming up from the 25mm tubing that is used right up to a 90mm adapter. So the large rainwater PVC pipes could be connected to give you a much larger capacity for storing a lot more feed. So the system's now low on feed. There's only about 50 grams in there to start with. We can see that it does distribute a little bit of feed at first. It's trying to feed the large dog, so it's trying to distribute the 30 grams. However, there you can see the feed stops coming out, or comes out at a slow rate and then stops coming out. The fourth LED will be illuminated after the timeout to indicate that the system's either out of food or there's a jam in the system. If the feed is filled back up, or if the system becomes unjammed, that light will actually go out, so it self-clears that jam or low feed error after the next successful feed. So you can see that fourth LED is now on. The 4 buttons on the side are the start, standby, feed, and reset. So reset to the demo mode, set those 2 demo nodes back on, which is to do with the Bluetooth functionality where you can pre-program them separately. So in standby, press the button for at least a quarter of a second. In start, press the button for at least a quarter of a second. So what that does is turn the timer on and off. So the interval timers will not decrease. So the times between feeding the dog will not decrease. And to feed a specific dog, we can hold down the feed button for a number of flashes. So hold it down for 1 flash and we're feeding the first dog. Hold down for 2 flashes or 2 seconds and you'll be feeding the second dog. So my Bluetooth adapter, the HM10, was used for my X Factor. I created a serial communication and then created an Android app to communicate through that serial communication. Inside that I had a JSON-like API that I created to communicate between the phone and the Arduino. I was able to read the current configuration of the current dogs. I'm able to command, so pressing start now, and changing between the start and the standby modes on the app. I can also write to the to the dogs and change any of the settings, so changing the names or the interval or the time. I also can control a feed, so I can manually command the feeding of one of the dogs. The app also has sensor readings, so you can either read the current dog weight for the dog that's detected at the moment, or you can read how much feed is in the bowl. With the weight sensors here, they will also be displayed the weight whilst it's in that automatic mode. If it is time to feed the dog, you can actually get those updates from the phone. It will tell you that it's feeding, and it will tell you the weights that it is measuring for either the small or the large dog. If you would be adding another dog, you could get the reading for that other dog by using the app to read the weight of that dog, particularly if it was just one paw or two paws of a dog. The app, you can add multiple dogs, so you can add additional dogs, and you can set the tones of those additional dogs. There's also a serial monitor, so we can send messages in that API format I've created. We can actually watch the serial monitor as well, so if we give a command, you can actually see those serial commands I'm giving there as well.